Hi, welcome back to the breadboard. As you can see in the picture, we have a Raspberry Pi 4 Model B. Bought this myself, got it sent from the Pi Hut over in the UK, and wanted to have a quick test of a few of its features. So the first thing I want to do is go through what we have on here, the specifications. So right off the get-go, this big shiny chip in the middle here is the new Broadcom BCM2711, which is a quad-core ARM Cortex-A72, which actually contains an ARM v8 processor, 64-bit, running at 1.5 gigahertz, so significantly more powerful than its predecessors that barely topped about a 1 gig. Maybe you could get a bit more than 1 gig out of it, but it's predominantly 1 gig, so we're about a 50% faster CPU. This also comes in 3 versions, a 1 gig, 2 gig or 4 gig of DDR4 SD RAM. The model I have here is the 4 gig version. I wanted to have something that I could potentially set up for a home server and have a few things running on it like Node-RED, a bit of a database, maybe some security stuff, maybe capturing some video from places or motion and pictures from a webcam and things like that. So I wanted a bit of extra horsepower to play with. It has gigabit Ethernet instead of the 100 meg of its predecessors. It has 2 USB 3 ports and 2 USB 2 ports. What else does it have on here? It has a Wi-Fi built in, which supports 5 gig as well as 2.4 gig, and it also supports a Bluetooth 5 and Bluetooth Low Energy. It does have a USB-C connector now, so you can't use your old power connectors and things. You have to get a USB-C one, and they recommend, if you're going to be loading this up with things, a 3 amp power supply, though it will work on less than that, of course, if you're not loading it up with extra hardware and things. Couple of other main features that are on here, well, the only other real main 2 features that are on here are these 2 video output ports. They are both HDMI, and the first one here will support HDMI up to 4K at 60 frames, but the second one will only support up to 4K with 30 frames. Now, from what I've seen on other reviews, there are some issues at the moment with being able to get decent frame rates and decodings, probably because the software has not been fully implemented yet, taking advantage of the hardware acceleration capabilities and things like that. Our output jack here still supports audio and video out. We've still got the classic camera connection and display connection over this side and camera connection here. So we will try the Raspberry Pi cameras. I've got a Pi Noir as well as a regular one, both 8 megapixel. We have a power over Ethernet connection up here. Now I don't have a PoE adapter, and maybe in a future video I will look at maybe making my own. I do have plenty of PoE injectors which would work at the other end of the cable. The only other standard things that are on here, what you've already seen before, is just the SD card slot. So no eMMC flash or anything like that at this point. If you want eMMC with a Raspberry Pi type of system, then you still need to go to the compute modules, if it's sticking with the standard official Raspberry Pis, that is. GPIO, same as before. Now there are some additional bits of functionality that are built into the processor, in that it has a lot more SPI and I2C channels. Not every single one of them is brought out, but I know from looking at the Broadcom chip specs, there are quite a few of them. Obviously, you can't have all those extras and keep the GPIOs running at the same time. You'd have to pick which pieces of functionality you want. Now, one of the significant not visible aspects of this is that the Ethernet and the USB are no longer fed through a USB port from the main processor. They're using a PCI Express bus to communicate with the USB controller, which means you should be able to sustain a lot more data throughput. And especially since we've got USB 3 on here, we should see significant improvements in connected devices like hard drives and stuff like that. And it also means that if your network is busy, then it shouldn't be impacting your USB devices and vice versa, because the networking through its physical interface is directly connected to the Broadcom chip now. It has the gigabit Ethernet built into the chip, so no more need for an external Ethernet controller as well. Power supply system down here, the only thing of note on this is that they haven't fully implemented the USB-C power management features, so certain power supplies that may be a little more dynamic and negotiate the supply settings may not work. So if you do have one and it doesn't quite work properly, try to change it for a different one. There's a little mistake on this, and obviously they're not going to be fixing it on any boards that are already bought. Hopefully they will fix it for future versions of the board though. That pretty much covers everything on the Raspberry Pi 4. So the next thing to consider is the operating system, of course. I'm not going to take you through the downloading and setting up of the SD card. I've already got one prepared here. I've got it on a 64 gig SanDisk UHD Ultra card, type 10. So that's ready to boot up. I've never booted it up yet, so this will be the first time I do it. And what I've loaded is Buster. Now Buster is the latest version of Raspbian for the Raspberry Pis. It is quite a big download. They've got several varieties now actually. If I go in here I can tell you the four that the ones that they've got. They've got the full-blown, effectively desktop kind. They call it Raspbian Buster with desktop and recommended software. This is a 2 gigabyte download. They have Raspbian Buster with desktop, so without the recommended software. That's just over 1 gigabyte. And then you have a Raspbian Buster Lite, which is only 426 meg. So you lose the desktop and things like that. You would need to pick which one you want to use, etc., etc. Now in this video, I'm just looking at the Raspbian Buster with desktop and recommended software. Once I set this up to be a controller for my home or something, I'll probably reduce it down to Buster Lite, so that there's a lot more memory space for other things. But anyway, that's the one I've downloaded, and I'll put a link in the description that will show you the process for setting up the SD card and plugging it in. So let me just stop the video there for a second, and I'll just plug in some cables. You notice these are micro HDMI, so you need an adapter or a cable that goes from micro HDMI out to whatever your monitor takes if you're going to be using a monitor with it. The standard things also still apply, by the way. If you on the SD image, on the bootable drive that shows up on your Windows PC, if you put in a file called SSH, all in lowercase, empty file, and just save it there, it will enable SSH by default. Also, if you put in the WPA config, I think it is, I'll put a note up saying what the file is, defining some of your network abilities, then it will automatically configure your Wi-Fi 2 when you first pair it up if you don't plug it into an Ethernet port already. So I'll do that to start with. I've set up a WPA config and also the SSH file. So I should be able to power this up, find its IP address, and then immediately connect to it over the network. Be right back. Okay, now we have an SD card in place. The WPA_supplicant.conf has been added to the file. I'll put the contents up on the screen now so you could see what it needs to be. Obviously you'd replace the SSID and the password with the ones that suit your network. My HDMI cable is plugged in. I will point the camera at the screen when I boot it up. There's really nothing to see here except a couple of blinky lights, so it'll be more interesting to see what's on the HDMI screen output. USB-C ready to plug in. I have this connected to a 5.3 volt 2 amp adapter at the moment. Okay, pointing at the HDMI screen, it is not easy to hide the crimes of a dirty screen. to the camera, I guess with the lighting. To the naked eye it looks pretty clean, but to the camera not so much. Anyway, this is like I said, Buster as of July 10th I think it was, and it's the full-blown desktop with extra software and stuff, so it's the big one. We should see it power up and then expand the file system before it comes on fully. So let's plug it in now. There we go. So it's expanding the file system, rebooting in 5 seconds. There we go. So that's just expanding out to the full 64 gig of the file system. Now it's going to boot up again. Now, as I said, I did have an SSH and a WPA_supplicant.conf file on the boot folder, so it should automatically connect to my Wi-Fi network and also to allow SSH to be enabled. Still busy booting. Surprised it doesn't put anything on the screen, but I guess that's maybe what they've done with Buster. See how long that takes. And there we are, and it's just popped up telling us that SSH is enabled. Default password for the Pi user has not been changed. Security risk, please change it, blah blah blah. So that's fine. We should also have, and it looks like it up in the top right corner, way up here, shows that the network is connected and the the Bluetooth is enabled. Didn't do anything to enable the Bluetooth, but the Wi-Fi should have connected to my network. Now I got a little adapter for a keyboard, so I'm just going to plug that in so that I can drive this screen here right off the bat, so that shouldn't take a minute to take effect. It's just a standard Microsoft keyboard and mouse combo, so it should pick up on it pretty much right away. And there we go. So I'll say OK to that, and it's asking us now, before using the Raspberry Pi desktop, there are a few things to set up, so press next to get started. So next, country obviously is not England, it's Canada. Let's head all the way up here. I guess one letter jumps to it, doesn't work. Pick Canada. Canadian English time zone is not at the Quachen. It is Ontario, so that was Edmonton. Go down to Toronto is more specifically where I'm at. So there's that done. And I guess we just say next. You could do all this through Raspberry Config too if you were doing it from an SSH session. But this is my first time booting up Buster. All right, change the password, so let's do that. Okay, next. Now it should have already connected to my network. If I have a look up here, I do not have, yeah, it's got an IP address already. It's already connected to my network. You can see here WAN Nort is associated with Oaks Clan Home, which is my home network, and it's got a local IP address. So even though it's asking me about these, I can just skip this because it's already configured. Now it's going to do automatically the operating system updates, so bring it up to the latest. So this might take a little while. Setup is complete, so now we'll do a restart. Still no network plugged into the actual Pi, not a hardwired one anyway. So much faster. Startup obviously is expanding the file system, and doing a whole bunch of housekeeping. Now it's all booted up and ready to go. We should see over here that the Wi-Fi is connected but nothing else. It says Etherlink 0 is down. Bluetooth is there, but obviously nothing is connected. And that's pretty much it. So let's see what default software we get with this full-blown version of Buster. This is not going to be a full-blown review of Buster software or anything like that. I'm just curious to have a look. So programming, Node-RED, BlueJ, Genie. Genie is the IDE, by the way. Very popular for doing all sorts of programming, including C++ and Python and Java and stuff. Greenfoot Java, Mathematica, Mu, Scratch, 2 versions. SenseHat emulator, so you can program things with a SenseHat without actually having one. Sonic Pi, never used that. Wolfram, I think that one went away for a while. Looks like it's come back again. Good mathematical type program. And Phony Python IDE as well. So that's there. Education's got SmartSim, never used that. We've got the standard LibreOffice suite. So we've got the calculator, the drawing package, the word processor, the mathematics, and LibreOffice Impress presentation software. Not sure what the base one is. Oh, database, base, okay. Internet, Chrome web browser, VNC viewer. Some people like to use the Firefox browser. Easy enough to load if you want to. We'll try out the Chromium one. From what I've seen, the Chromium one actually performs quite well playing YouTube videos and things like that. Some of the other ones consume a lot more processing right now. Maybe they're just not optimized for this. Sound and video, VLC media player, graphics. We've got an image viewer, Minecraft Pi and some Python games, accessories, SD card copier, task manager, terminal, text editor, help, preferences, Raspberry config, recommended software, etc., etc. So I wouldn't say there's a huge amount extra. I would have to compare it to the standard desktop. Maybe it doesn't have so much of the educational and programming software in that one. But it looks like quite a nice comprehensive set of programs. Node-RED is more of a runtime environment. You program Node-RED in Java and things. Node-RED is a runtime. I will be doing a whole bunch of experiments with the Raspberry Pi 4 with Node-RED. It is my preferred workflow program of choice for Linux-based systems. So my BB400 from Brainboxes, for instance, runs Linux, and I like to use Node-RED on it. My RevPi Core 3 is also a Pi-based programmable logic controller, industrial style again, also running Raspbian or modified Raspbian anyway. It's got a core runtime in it for industrial control. And again, I like to run Node-RED as my main program. There's a lot of ones that you can get which don't cost much money or very small amount compared to what some of the bigger packages for Siemens and people like that might be. But more than enough for a lot of home office, small industrial applications and things, and to act as a gateway because it supports so many different things and it's got a huge community following. Anyway, that's all of our basic checks here. I think if we do go into a terminal here, we should be able to run something like htop and see what is happening, see how busy the processor is and things like that. And you can see here, not busy at all. Let's try and move this screen here. I'll put that up there. So the processors are very, very little utilization. CPUs, memory, 2 gigs out of the 4 gigs. Sorry, 212 megs out of the 4 gigs. So very little memory currently being used, which is good. So Let's bring up a YouTube page. My Wi-Fi is connected, so I should be able to, and see what it does with that. So let's go to youtube.com/breadboard CA, which is my own channel. Shouldn't get any copyright strikes for using that one. You can see the memory utilization, the CPU utilization jumping up and down like crazy right there as it's pulling in these web pages and graphics and things. So yeah, let's just run this, try this video here. It's a 1080p, 30 frames a second. So we'll just run that and see what it does for utilization. This monitor doesn't have speakers on it. So it's auto 360 because it's a shrunk page. Let's take it straight up to 1080 HD. Yep, so that's where it's at now. What is the info for geeks thing? Just see what it says. Oh, I think you've got to click in the screen to get that. Yeah. Stats for nerds. So it's dropped a few frames, 35 frames initially, but it is running at 1920 by 1080, 30 frames a second, and it doesn't look like it's dropping any more frames with this right now, which is excellent. Connection speed, yep, way up there. Network activity, buffer health is good. If I make that full screen, dropped a few frames while it was moving it there. Yeah, it's dropping the odd frame, which I think people have found before too. But the nice thing here is that it is not saturating the processors or anything like that. So for multitasking, it would be just fine. Let's go back to normal view. Yeah, a little bit of a lag there, freeze while it's switching things. But overall, I mean, if you're using that for casual browsing and things, that's not too bad. If you're trying to watch some gaming or something, it might be a little bit frustrating if it was losing a few frames, but it doesn't seem to be doing too bad at all. Although that messing, it's only dropped 74 frames out of 4,000. Yeah. So that's not too bad. If I open another couple of sessions, let's just duplicate. So we'll leave that first. You can see the CPU is jumping up there considerably while it's loading this page. Yeah, I think with the Wi-Fi connection, it's just a little bit slow. Hopefully, I don't know whether it connected to my network on the 5 gig or the 2.5 gig. I've got both available to it. But it's a unified network. They don't show up separately. It's the same SID and everything else. So let's pick a completely different video from my site here and let that one play separately. And is that one doing? Yep, that one's running HD as well, 1080p. So there we go. We've got two videos running here now. That one seems to be running reasonably smoothly. I think I'm talking here and not doing much animation. Let's jump in a little bit. Actually, the way to check this better is to drag that out and do it like that, I guess. So it did stutter a little bit there. Yeah, it's having a little bit of a hard time. I think that might be because of the network connection, not the processor. So what I'm going to do is I'm going to plug in a gigabit network connection, or 100 megabit anyway, and see if that improves things. Well, it's connected the Ethernet port. They're both connected now, but they should be okay. So still getting a little bit of lag occasionally. I don't know if that is from the internet or whether it's from my Raspberry Pi 4. I have to do some investigation. Certainly seems to be taking a bit more of the CPU up. It's maxing out some of them, so it's getting close to the limit there. Haven't done any updates, of course. It didn't let it do the upgrade, so there might be some updated encoders and things that would make this run a bit faster. Anyway, I don't want to spend too much time in here. I'm just doing a quick run through all of the different features and things. So it is dual monitor support, and you'll see plenty of videos that have shown that. I'm not going to worry about it right now. To show you, we will go and use some of those features as we go through the different videos doing some experiments with this. So let's get back to the board, and I think what I'll try and do is hook up a camera first, the Raspberry Pi camera, and then we'll hook up a Raspberry Pi screen and see how well that works right out of the box. Okay, I've stolen the official Raspberry Pi, the original one, LCD screen from my Octoprint server, and I've just hooked it up into the Raspberry Pi 4. Haven't changed anything else except I actually think it might even work with the other HDMI still plugged in, but we'll find out. So here it is. It's off right now, so let's just plug it in again. I haven't done anything else except hooked it up. Let's see if it works. Well, it's doing, there we go. That's a good start. And there we are. Booted up nicely. So, does the touch work? Yes, it does. Resolution work looks fine. And let's see if we can do an internet. We'll go to Chrome again. We'll pull up the same video, see what it does with this. And there we go. So, that was pretty painless. 2 power wires and the flex cable. No other configuration changes whatsoever, and we're done. So that is excellent. Let me just pause the video a second. I'll see if I can hook up a little speaker to this and to the actual audio output of the Pi, and see if we get audio as well. Okay, found a, stuck to my bench, little speaker microphone, speaker thing. So I'll just plug that on my bench, and we'll just plug that in. I can check you can change your charging mode. And there we go. That's working fine too. So, excellent. Now we have proved that even the Raspberry Pi 4 with the original Generation 1 LCD display will work, which I didn't expect it not to work, to be honest. So that's great. Let me just stop this video. Let's just shut this down, and we'll try and boot up again with both the LCD screen and an HDMI screen. Now, which one is going to be... Oh, look at that. That is interesting. It's actually managed to boot up both of them without an issue. That is rather good. So here I'm on the back one. Let me just move the trash can so you can see. And now I'm back to the front one. Now I wonder, just out of curiosity, will it work with 3? So I may not be able to show you it because the one I'm going to pinch is. So it looks like if you have 2 HDMIs and the LCD, it defaults to the LCD and the first HDMI screen. And that's okay, I guess. You know, it would have been really impressive if it actually worked with 3 screens. And I think from a software perspective, I think that's something that could probably be enabled. Unless it's literally switching part of the GPU from the LCD screen to the external screens, and it can't do that with the second one. Anyway, let me just unplug that, get my monitor back up and running on my camera, and we'll continue. So I guess what else is there to look at? I guess one of the things we can do is plug in an external hard drive and see if it sees it right away. That would also be a nice thing to know. Don't see why it shouldn't. So I have one here. It's already been formatted with ext4 partition. So I should be able to plug this right in. So just to start with, let's go to the file manager. Let me just zoom in on this little one on the LCD for now, because I can. There we go. And not complete. Oh, I just noticed it came right up because it saw it, and it's asking me to open it in File Manager. So let's do that. There we have Media Pi Drive 1. Alrighty. So I actually have a USB 3 drive as well. This is from my Apple that I upgraded the solid state disk inside of it quite a long time ago. This one is getting written to by another file system, so right now it's in this nice little Transcend drive here. It's a high performance SSD. So I will plug that into the USB 3 port and see what happens there. Be careful not to short anything out. Oh, helps if I plug it into the USB 3 and not the Ethernet. And I think I just made it reboot. Yeah, I mean, it's too much off the USB ports. Just unplug the bigger hard disk drive. I just drained it. Rather silly. But that's, you know, what testing's all about, right? Let's see if it'll boot up this time. You can see we've got the blue light on indicating it's working. That's on the USB 3 port. And there it is, P drive 1, and I do have actual pictures in here. This is just from some cameras I was playing with a different piece of software for the Raspberry Pi. There's rather a lot of images on here. They're all JPEGs. Theoretically the viewer should show them, which it does. These are all taken at night by the look of it. Let's go to a different camera. Yep, there we go. So this is just a webcam. Going to be doing a separate video on that. Not a webcam, an IP cam. So definitely taking and making use of an external USB 3 hard disk drive. Let's see if I can have a quick performance check on it. One moment. Okay, so I just installed HD Palm. It's a simple little hard disk performance tester. And so first thing you need to do is just look at what disks we have attached. And we've still got the high-speed one right now, the USB 3. So you can see it here as SDA1, and the SD card is MMC BLK OP1. So That would just be BLK0. The P1 is the partition. So if we run HD Palm with a -T parameter on the first one, it gives me some kind of error, but it still performs the test for me. As I say, this is a class 10 device, and I was doing the read test, and it managed to get 43 megabytes per second, which for an SD card, that's not too bad. Could be better, but it's not too bad. Now let's do the high-speed transcend and see what we get there. So that would be running the same command, but /dev/SDA1 instead. This is just doing reads, but you know, the writing would be a little different. But I'm just doing simple testing here right now just to see what it's like. And that is almost 10 times faster. That's 364 megabytes per second through that USB interface. So that's pretty darn good. Now, I'll disconnect that drive and I'll hook up the physical hard drive again on the USB 2 port, and then we'll redo the test on that one just to have a complete picture. See if I can do it without causing it to reboot. This would be in the USB 2. Okay, no reboots, that's good. And it's complaining that I didn't eject it, but we were only doing reads, so that's okay. So we'll just say okay to that. Don't care what's on it. Actually, there's nothing on it, but that's fine. Let's just close that. So if we do the df command again, so remember we had 364 meg on the solid state drive, 43 meg on the internal SD card. So let's just run df and it should tell us it's on the SDA1 as well. So because I've unplugged the other one, it's obviously taken over the same name. So we'll do SDA1 again. Remember we had 364 megs last time. This time I'm just going to do it on that physical hard drive, spinning disk one. And ooh, that's even worse than the SD card. So that's over USB 2 and to the hard disk, and that's 33 megabytes per second, which is pretty lousy. Let's plug it into the USB 3. USB 2 is pretty darn limited anyway. So let's plug it in the USB 3 port, even though it's a USB 2 hard drive, and see if we get much better performance. It's probably going to complain. Here is it. Okay, just cancel out of that. See if it's come up with the same assignment. Yes, it has. So we'll run it again. It was 33 megs before. See if it's any significantly different. No, exact same speed. So the limitation is probably the hard drive itself. Actually, the way to prove that would be to put the solid state one back in. So that's 33 meg on the physical spinning disk. Let's unplug that again. On the solid state drive, we had 350 megabytes almost. So let's plug this into the... This is the solid state one again now. That we got 364 megabytes per second. So the solid state drive is basically on USB 3 is performing 10 times faster than the spinning disk on USB 2 or 3. So let's just make sure what it's come up on. So it's come up again on SDA1. It's only a 500 gig drive as opposed to 1 terabyte. So let's run the same test. Now it's on USB 2 this time, remember, not USB 3. Let's see what it comes up with. Oh, so that was pretty pitiful there as well, only 32 megabytes per second. Let's just flip it back to the USB 3 one. Just to make sure it's not something that we're doing. Should still be SDA1, which it is. Now we'll run that again. and we're back to 350. So USB 2 on the Raspberry Pi 4 is still pretty darn lousy. If you want to get some decent performance with an external hard drive, definitely use the USB 3 interface with a USB 3 drive. This other hard drive, this is quite old, so it is possible that it's not even a more up-to-date USB 2 speed. That's just what I had. So I mean, it definitely works. So as far as having a terabyte of storage available to your Raspberry Pi, if you're not trying to write too quickly, for instance, streaming video to it, then it would still suffice. But using, a solid-state drive with a true USB 3 interface on it, definitely the way to go. As you can see, if we're getting 350, 360 megabytes per second transfer rates onto that, we've done pretty much enough for the moment. I will be doing some separate videos trying to set this Pi up to, for instance, boot from the solid-state disk. I have some other ones too, which I'll try and set up on USB 3. We'll set it up as a bootable device, so you wouldn't even need the SD card to boot from. And we'll see how well that works. What have we done today? Well, we've had a quick look at the new features of the Raspberry Pi 4, just a quick overview. We've had a look at the how quickly it powers up, so it's quite reasonable. It's got on the Buster full-blown version, it's got quite a reasonable set of software available to it. The performance, which is one of the biggest things I was more interested in, is exceptional on USB 3 compared to the Raspberry Pi 3, or using the USB 2 port, which is all there is available on the Raspberry Pi 3. And of course we've got gigabit Ethernet. Haven't tested that yet. We'll do that on another video when we start looking more at some networking performance and a little bit more detailed look. I like the fact that I was able to use my old LCD display right off the bat. I do have some other LCD displays, but they're all HDMI attached, so I will be hooking those up. It'd be nice to have like a two LCD displays of the same kind of size, but maybe something that you could have rack mount if it was an industrial controller or something like that. I also do have on their way to me a 3 or 4 adapters. I had a whole bunch of old laptops given to me a little while ago, and I salvaged the screens out of them, but directly as they are, they can't be used by the Raspberry Pi. But I did some digging and found that there are some cards. You can get them from eBay and lots of other places. Banggood. I ordered mine from Banggood, paid for them myself. They're not being sent for review free of charge or anything, and they should be here. It might be another couple of weeks before they finally get here, but when they do, I'll be trying them out and showing you how you can use an old laptop screen. They're not touch screens, but nevertheless show you how to use an old laptop screen on a Raspberry Pi or a Windows PC and things like that. Okay, as a final test, I've plugged in a Raspberry Pi Noir Camera, which is the one that has a little bit of infrared capabilities built into it, and I have enabled the camera in the Raspberry config, and what I've had to do is install my MJPEG, which I haven't put on here. I've actually shown how to do that before, and there are plenty of videos how to do it as well. And once I've done that, now I can actually create a streaming server that I can access via a web browser. Need to go in the right directory. Come on, don't want that. Okay, and we should be able to run just so that now should start something that's accessible to the web, which is there. That's now running. So if we open a browser now, that should give us an an MJPEG streamer base page. Now I have the webcam, which is sitting right here, and I can do that in pretty much real time. So you could actually pull that from pretty much anywhere you like on the network. If you set up a firewall, you could access it that way as well. So that's good. We proved that these are legacy webcams as well. So a webcam will work fine on the new Raspberry Pi 4. The screen will work fine on the new Raspberry Pi 4. External hard drives work fine. Really huge improvement in performance when you use the USB 3 for the webcam. Really huge improvement in performance when you use the USB 3 for your external hard drives, especially if they are also USB 3 and solid state in excess of 360 megabytes per second, which is pretty awesome. So that's got the makings of quite a nice desktop replacement for basic use, or as a media server, or as a security webcam kind of recording collection device as well. So we will look at some of these options in future videos. In the meantime, if you like this, give us a thumbs up, and if you didn't, well then don't. But please come back for more as we start experimenting more and more with this Raspberry Pi 4, and I'll see you soon. Bye.